What's up guys, welcome back to the channel. Today on this video we'll be doing Cramer's rule intro for 2 by 2 matrix. Alright guys, before we continue with this intro, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I've made lots and lot of videos on mathematics, and also I've solved previous question papers as well. Right guys, let's continue with this intro. Now, Cramer's rule, just in case you didn't know, it's a rule that we use to calculate for x and y. Usually we use simultaneous equations to calculate for x and y. Sometimes you use elimination method. So Cramer's rule is one of the rules that we use to calculate for those variables most of the time. Usually we have two equations, and then we find the determinant, and then we find the determinant for x and the determinant for y. So how do we actually do that? So let's say you have equation 1 where the coefficient of x is a1 plus b1, which is the coefficient of y. All this is equaling to the constant 1. There we go. And then this, let's say we call it the equation 1. And in equation 2, we have the coefficient of x, which is a2, plus the coefficient of y, which is b2. All this is equaling to c2, which is a constant. Now, as you can see, these two equations here, we have x plus y with their coefficient for both equations. All these are equaling to the constant. Now, if you still remember from our previous videos, when we calculate the determinant, we only take the coefficient of x and y and make them our entries so that we can have our square matrix. So for example, here on this one, we're going to take the first entry, which is a coefficient of x, and then the second entry, which is going to be the coefficient of y on the first equation. And then the third entry is going to be from the second equation, which is a coefficient of x here. And then the fourth entry, which is going to be the coefficient of y there on the second equation. Now, this is when we calculate the determinant of these two equations there. So if we continue, we know that the determinant is going to be the product of the first entry and the last entry, subtracted by the product of the third entry and the second entry. There we go. So this here is going to give you the determinant. Now, in order for us to calculate x, we also need to calculate the determinant for x. Guys, when you calculate the determinant for x, your square matrix now start to change. As you can see, we have our constant here. Remember, on this here, on this square matrix here, by the way, on our first column, we have the coefficient of x's there. Instead of putting on the coefficient of x's, we're going to put the constant. So for the first entry, is going to be the constant on the first equation, and the third entry is going to be the constant of the second equation. So basically, when we are looking for determinant for x, we substitute or we swap the entries of the coefficient of x's with the constant, and then we keep b1 on second entry and then b2 on the last entry, because these are for y. And then from there we continue, we calculate by doing the following. We multiply the first entry with the last entry, which is c1 multiplied by b2, minus the product of the second entry, which is b1 multiplied by the third entry, which is c2. So this here is going to give us our determinant for x. As for the determinant for y, we're going to do the similar thing that we did then. But then on the first column, we're going to continue. Now this time we're going to bring back our coefficient for x, which is a1, and then a2 there. Remember, this here, guys, is the original square matrix. All right. And then from there, on the second column, we're going to now substitute our constant for the equation 1 on the first row, and then constant from equation 2 on the second row there. This is what we do when we are calculating for dy, because on the second column it's actually the coefficient of y. As you can see from the original there, b1 and b2 are the coefficient of y, but this time around, since we are calculating for determinant for y, we substitute with the constant for equation 1 and equation 2. Now for dy, which is a determinant for y, we also gonna do the same thing there. We multiply our first entry, which is a1, with our last entry, which is c2, and this is going to be subtracted by the product of the second entry, which is c1, and the third entry, which is a2. There we go. And this here is going to give us dy. Now when we calculate for x, the following equation must take place. You divide the determinant of x with the determinant that we calculated here. And then for y, we also going to divide the determinant of y with the determinant that we calculated there on the original. So basically, this is how you calculate x and y. All right, let me try to use the actual equation so that we can able to see exactly what we are talking about here. All right, guys, so here are the two equations that we will use as an example to explain Cramer's rule. All right, before we continue, I hope you know how we can create the square matrix. So first, we need to calculate the determinant of these two equations. Like I said before, we need to take the coefficient of x on the first equation for the first entry, which is going to be 2. And then for the second entry, we need to take the coefficient of y, which is a 3 on equation 1. And then for the third entry, we take the coefficient of x, which is a 5 on equation 2. And then for the fourth entry, we're going to take the coefficient of y, which is negative 8 on equation 2. Now from here, we calculate our determinant. Guys, when you calculate our determinant, like I said before, you multiply the first entry, which is 2, multiplied by the fourth entry, which is negative 8. The product here is going to be subtracted by the product of the second entry and the third entry. And this here is going to give us negative 16, negative 15. So all in all, this is going to give us negative 31. There we go. Now that we defined our determinant, it's time for us to find the determinant for x. Now, when you're looking for the determinant for x, like I said earlier, on the first column whereby we have the x coefficient, we're gonna substitute with our constant. Now on the first entry, we're gonna put the first constant from the first equation, and then on the third entry, we're gonna put the constant from the second equation, and then we keep these y coefficient as they are for this one, which is 3 and negative 8. There we go. And then from there, we calculate determinant like we usually do. All right, so remember, when you calculate the determinant, we multiply the first entry with the last entry here. And then the product of this is going to be subtracted by the product of the second entry with the third entry. This here is going to give us negative 40 and plus 9. And all in all, this is going to give us negative 31. There we go. So this here is our dx, the determinant for x. Then we calculate the determinant for y. Now here things will change. Remember, on the first row now, we have to take back the coefficient of x, because now we're calculating the determinant for y. So the coefficient of x, which was 2 and 5, we have to bring them back. But as for the second row, whereby we put the coefficient of y, now we're gonna substitute this coefficient of y with our constant. Now on the second entry, we're gonna put the constant on equation 1, and then on the last entry, we're gonna put the coefficient of equation 2. Then we start calculating the determinant for dy. Again, we're gonna multiply the second entry with the last entry there, and the product here is going to be subtracted by the product of the second entry and the third entry there. And then if you continue, this is going to give us negative 6 minus 25. And all this is going to give us negative 31, like I said before, guys. But before we continue, just in case you don't know much about how to calculate the determinant, I left a video on the description. Go and click on that video so that you can understand how we calculate the determinant, as well as how to create the square matrix from two equations there. So I'm going to leave those videos there on the playlist. Click on that playlist so that you can watch from video number 1, where I introduce determinant and also how to create a square matrix. The very same playlist is going to pop up on the top right of this video. You can click on that icon then. All right, so let's continue. So when you calculate for x, the formula goes like this: is the determinant of x divided by the determinant, the original determinant then. So if you look at our determinant for x is negative 31, and then our determinant is going to be negative 31 as well. So meaning x is equaling to 1. Now for y, we're going to do similar. We're going to take the determinant of y and we divide it by our determinant then. What is the determinant for y? Is going to be negative 31 divided by our determinant there, which is negative 31. So y is equaling to 1. So we can say here, let me create more space here, guys. We can say here x is equaling to 1 while y is equaling to 1. You can also check your answer if it's correct by substituting both x and y on one of the equations there. So I'm going to substitute on the first equation. If I say 2 multiplied by 1 wherever there is x plus 3, remember y is also 1, this must give us 5. All this is equaling to 5 from the equation. So this is 2 plus 3 is equaling to 5. There we go. So we can say x and y is equaling to 1. Guys, I hope you managed to understand this. This was a bit long, but it was not that difficult. All you needed to understand is how to calculate the determinant and also how to create your square matrix when you're given two equations. As for calculating for x and y, you need to calculate the determinant for x, where you substitute the x coefficient with the constant. And also for y determinant, you need to substitute the y coefficient on the square matrix with the constant. So I hope, guys, you managed to understand this. If it so happens that you didn't understand, you can ask on the comment section, and also you can rewatch the video so that you can understand better. But if this video helped you to understand how to calculate for x and y using Cramer's rule for 2 by 2 matrix, do not forget to like, share, and also subscribe to the channel. Guys, thank you very much for watching. Until next time, cheers.